Hello, I am Aina, and together with my team members, Amalin, Yinyi, and Rosaida, we are from Group 1. So today we're going to do a presentation on analysis and prediction on rate of return items for Superstore dataset. So today's agenda will cover on these 9 main topics.
Starting with the introduction, since retail sector is a huge dynamic sector, it plays a significant role as one of main contributors to the global economy. Hence, data analysis is essential in delivering insightful information about business factors, sales patterns, consumer behavior, as well as product performance. Thus, this presentation outlines the analysis of the transactions from the global Superstore dataset, emphasizing on SEMA paradigm. We have 3 objectives, which are determining the yearly return trend based on price of goods. Second is to develop models in predicting the rate of return items by category and shipping cost, as well as the third to evaluate models through performance matrix. In the dataset description, the dataset that is used is Global Superstore with 29 attributes and 51,000 rows of transactions. In the sampling section, this global Superstore dataset consists of several tables, which is made up of 1 fact table and 4 dimension tables. These 4 dimension tables are customer, order, category, and salesperson respectively. These tables form a star schema in which a merge function is used to combine all attributes from different datasets to ensure that each table has at least 1 common attribute. Next, in the explore section, we use 3 types of analysis to conduct in the explore section, whereby univariate analysis is used, as well as bivariate analysis and correlation variable. Next, I will proceed with my teammate Yini on the modify section.
Thanks, Amalin. In the modify phase, with the dataset imported into modification workspace, we conduct an exploratory analysis to understand the mean and max limit value of the variables in the dataset. This analysis helps us become familiar with the data and its characteristic and help us to identify anomalies. Next, please. Then we select the attributes to be retained in order to streamline the dataset and focus on the variables most relevant to our objectives. Out of the initial attributes, we identified and retained 13 key attributes, as you can see on the screen, and we decided to drop the remaining attributes as they were not directly aligned with our objectives or deemed less significant for our analysis. Next, please. We use replacement tool to deal with missing value. We implemented a lower limit of 0 for the discount variable, ensuring consistency in our analysis. Mean absolute deviation was also used to handle missing value in variables such as net price, and profit. To evaluate the effectiveness of the replacement process, we analyzed the result using the replacement count window and introduced additional columns for the replacement variables. Next, please. On top of that, we also utilized the impute node to handle missing value in our dataset. Mean imputation was used for interval data variables such as net price, profit, and shipping costs. This approach will allow us to estimate and fill in missing value while preserving the distribution and characteristic of the variables. The result of the imputation step using mean were displayed in figure 8, where you can see the reduction in missing value for the mentioned variables. Next, please. To validate the effectiveness of our modification process, we examine the exported dataset. As shown in figure 9, the histograms indicate that no missing or 0 values were identified in each column, which means our imputation is effective. Next, please. The clustering variable analysis was also conducted using the variable cluster node to uncover relationships and correlations among the variables. This analysis involved grouping variables based on their similarity and exploring the dynamics within each cluster. Figure 10 presents the result of the clustering analysis, revealing high correlation among the variables within each cluster. Next, please. The analysis resulted in 2 clusters. Cluster 1 comprised of net price, shipping cost, and profit, while cluster 2 consists of order year. The datagram output shown in figure 11 explains the variance proportion for cluster 1 and cluster 2, and additionally, figure 12 demonstrated a clear and high correlation between these 2 clusters. Next, I will pass on to Rosada to walk us through the modeling step.
Thank you, Yi. In the next section, we will talk about the modeling part. Before that, we start with data partition, whereby we divided the modified data set into train and validation data set into 50-50 ratio that consists of training and validation sets. Then we use control point to connect both training and validation data sets for modeling purposes. Next. The first model that we use is decision tree, whereby we can see from this diagram how each variable correlates with return variable. From figure 16, it shows that expansion of decision tree automatically created by the system, where category, price, and shipping costs were among the top 3 highest net log P values with written variables. Next, please. The second model is interactive decision tree, whereby we can see from figure 18, it shows that category, shipping cost, and net price were among the highest priority and correlation with target variable return, which makes both decision tree and interactive decision tree to have shipping cost at the highest hierarchy. Okay, next, please. The third model is gradient boosting. It is an assembled learning algorithm that can be used to improve performance of by combining multiple weak learners created during decision tree process. From figure 20, it shows that shipping cost has the highest variable importance with return target variable, followed by category and net price attributes. Next, please. Before we perform logistic regression and neural networks algorithm, we use transform variable to transform the data into number of bins for further analysis that helps to stabilize the variances and to correct non-normality in variables. Figure 21 shows the 8 variables: category, net price, profit, shipping cost, quantity, return, and salesperson gender were assigned to 4 bins, whereas the remaining 3 variables such as order month and order year were set to none due to not being used for modeling purposes. Next, please. After we perform transform variable, we use logistic regression to classify data into 2 or more categories, and it predicts the probability of event occurring. We use confusion matrix to identify performance of this logistic regression using accuracy. Figure 22 shows that shipping cost has the highest variable importance with return as the highest as the target variables, followed by category and net price. Next, please. The final model is neural networks. Neural networks inspired by the way of human brains works, similar to neurons in human brain. The overall result obtained from neural networks model consists of score rankings overlay, fit statistic, iteration plot, and output of the model as shown in figure 23. I'll pass to my teammate Aina for SS part. Thank you.
Okay, moving on to the assess part, control point node is used to connect all models in order to combine all data from the interconnected nodes into one center. Next, the model comparison node was connected to control point to allow all models to be evaluated and assessed using various benchmarking criteria. Next, model comparison node allow us to obtain metric of each model. From these values, accuracy was calculated using the formula where the number of correct predictions are divided by the total number of predictions. We obtain the highest accuracy with 90%, followed by interactive decision tree, gradient boosting, logistic regression, and neural network. This can be due to the fact that decision tree is known to be a model that is relatively easy to train and use to solve classification problems. It is robust to noisy data where it can perform well when data contains outliers. Price, net price, and profit have extreme value where decision tree could tackle this issue due to its suitability to be used in messy data. In order to summarize this whole project, we have covered 5 steps in SASEMA, which consists of sample, explore, modify, model, and assess. During sample step, dataset undergoes sampling, importation, and merging from different sources in order to As for explore, we obtain insights into the dataset's attribute and correlation were obtained through the utilization of bar charts, histogram, and bar charts during the process of EDA. Next, pre-processing steps were conducted during modify step in order to mitigate bias, handle missing values, and explore correlation among attributes. During model step, 5 algorithms as listed here were used in this project to predict the target attribute return. Lastly, in assess, accuracy of various models were evaluated and compared through the model assessment using model comparison. Among the 5 algorithms, both decision variables, which are category, shipping, price, are significantly influence the prediction for the Superstore dataset. Research shows that decision tree displayed the highest rate of accuracy with 90%, followed by interactive decision tree and gradient boosting. In our specific dataset, variables such as price, net price, and profit have extreme values. Hence, it shows that decision tree is resilient and can accommodate and interpret data with extreme values without compromising its performance. Overall, we can conclude that the rate of return items is highly influenced by shipping cost, category, and price in Superstore dataset. So throughout this whole project, we have come with some recommendation, and our first recommendation is to have in-depth understanding of prediction due to us only reporting on the accuracy of neural network, where we can also include other details that is possible to be reported. For the second recommendation, we would like to further explore on other attributes like salesperson gender due to its having balanced data, which make it suitable to be used as target variable as well. And the final recommendation is to perform feasibility study and implementation of other algorithms that are available on SaaS Enterprise Miner, which might increase our Superstore dataset. So these are all from us. Thank you.